Hello, Maurieo. Maurieo reviews Engineering Math Quiz 10. Hello. Well, this is the last of the maths quizzes for this semester that we get to review. So, thank you for watching and following through the maths reviews. I hope it's been helpful for you. So let's transition to the big screen now and see what it is that we have for you. And first of all, we'll bring up the formula sheet and then the model answers. Okay, so let's see if we can close the tools pane, and we're working here on the left. Well, the first question is fairly straightforward. That's just a straight anti-differentiation, really, which we do in things. The first thing to do, of course, is to get everything in a single line. That sort of works quite well. Having everything in a single line, so that we can just have a look at how things are going. So 3x squared. Well, we know that when we integrate, it's going to go up a power, so that's going to be a 3 there, and then we usually divide through by that power, so that's going to give us x cubed. And then if we just look at x cubed, we can see that that's, if we differentiate it, which is going back the other way, we get 3x squared, so that's fine. Now x to the power of 1/3, so we're going to add 1 to that. 1/3 plus 3/3 is 4/3, and then we sort of divide by the 1 over that, really, the reciprocal, which is 4/3, so we divide by 3/4. So okay, so let's differentiate that. So we get minus 3/3 minus 1, so that's x to the third, times 4/3, so we get 4/3 times 3/4, which gives us x to the third. So that's a pretty straightforward one there. 2 marks, so that's money, pretty easy money, that one. So that's all very good. So just here on the formula sheet, I may as well get the integration on there up and running so that we can just see what we're dealing with there. Okay, so this is integration here. So B, now this is one with intervals, so we've got to first of all find the definite integral, I think it's called, the integral, find that, and then we've got to evaluate it between 0 and 2 pi. So 5 cos x, if we just look over here, we can see that cos x becomes minus sine x. Oh, sorry, no. Yeah, if we've got cos x as the answer, then that means that we've differentiated or we've integrated sine x. Yes, if cos x is the differentiation, then the integral must be sine x. And then we know that if it's 5 sine x, it's just going to stay the same. So if we go 5 sine x and we integrate that, we just get 5 cosine x. So pretty simple there. No big deal there. They just flip one to the other. So now we've got to evaluate it between 0 and pi by 2. So what that means is we substitute 5 sine pi by 2 minus 5 sine 0. Now sine of 5 pi by 2, sine of 90 is 1. So 5 times 1 is 5, and the sine of 0 is 0. So the answer is 5. Okay, so fairly straightforward there. You possibly could put little square brackets around each one of those just to make it a little bit clearer. But yeah, pretty straightforward. 2 marks, so that's nice easy money there. All right, so now we come down to the question C. Okay, now C here, what we've got to do, we've got 6, 3x plus 2. So generally what we would be happening is we would with e, if we look at e to the x, so differentiate or integrate, oh yes, we've got e to the ax here, that's differentiation. It doesn't, nothing for sale over here, but we can see that e to the ax becomes ae to the ax, so the e to the ax bit stays the same, so clearly the e to the 3x plus 2 is going to be the same, but if we differentiate the 3x plus 2, we can see we're going to get 3 there. So that, if we like differentiate that, that's going to stay the same, but we're going to get this 3. So 3 times 2 is 6. So we just need a 2 there. So we get 2, 3x plus 2. So if we go over here and we differentiate that, remember integration is going up a power sort of thing, and differentiation it's coming down. So one's the opposite of the other. So if we integrate that to get to there, we've got to differentiate to go back the other way. So we've got this here, and if we differentiate that, we differentiate the 3x plus 2, which is 3. 3 times 2e to the 3x plus 2 gives us 6e to the 3x plus 2. So yeah, that's all good. All right, now this next one here, yes, gets a little bit trickier, and see, we haven't got any marks allocated for these ones, so I can't make my little comment. So what we've got here is cos x sine x dx. Now, if we look over on the formula sheet, we'll see in here it is here, that if the function is a function times its derivative, then the integral is a half times the function squared. Okay, so if we know that cos x and sine x here are, like if we integrate, differentiate sine x, we get cos x. So, and similarly, cos x, if we do that, gives us minus sine x. So if we look here at cos x, and we say, well, that's going to be our, in this case here, our g of x, okay, then our g dash of x, in this instance here, our g dash of x is going to be negative sine x. Okay, negative sine x. So if we put a negative in there, that's going to counteract that negative that's generated there. So we get negative and negative a half cosine x is our derivative, using this little formula here, where you've got the function times its derivative. So that's a half x. So that's where that works out. So let's that gives us the formula. So we've got g of x equals cos x, g dash x equals negative cos x. So dy by dx equals negative a half cos squared x, which is what we've put there. So if we want to check that out, so we let u equal cos x, dy by dx equals negative sine x. So y will equal negative a half u squared. All right, that's from there, because we've let, yeah, and dy by du equals negative dy by du, in that case there, would be negative u, because you'd go 2 times negative a half is negative 1 u. So dy by du equals negative u, which equals negative cos x. So therefore we get dy by dx equals dy by du dot du by dx, which equals negative sine x times negative cos x, which equals sine x cos x. So if we differentiate the function that we've ended up with by substituting in there using the chain rule, yes, we come back to what we started with. So that's a pretty good sign that everything's all good and fine and dandy. And yeah, we can move on from there. So now we have to evaluate it. So we go, first we evaluate for pi by 2, and then we substitute, and then we minus the evaluation with pi by 4. So a half cos squared pi by 2 minus negative a half. So that's negative a half there. Sorry, I've got the negative up the top. It's a little bit untidy, but negative a half cos pi by 2 minus negative a half cos pi by 4. Now, cos of pi by 2 is 0. So that's going to go to 0. Now, cos of pi by 4 is 0.7071, which is the square root of 2. No, that's 0.7071. And if we square it, we get 0.5. 0.5. And a half of 0.5 is a quarter. So we get minus negative a quarter, which equals 1/4. So just recapping on that one, we used this little thing over here where we've got a function or a derivative times its function. And so we used that to get our integral here. Okay, and then we checked that out by differentiation. We differentiated that. So we differentiated negative a half cos x squared. We let u equal cos x. Dy by dx equals negative sine x. Y equals negative a half u squared. Dy by du equals negative u, which equals negative cos x. And we put them all together. And we came back to where we started with, cos x sine x. So you were quite happy that we've had that right. Then we evaluated that across the interval to get an area under the curve of a quarter. Now this next one, the integral of x squared cos x cubed. So what we did there is let u equal x cubed. So du by dx is 3x squared. Therefore, du equals 3x squared times dx. And du by a 3 equals x squared dx. So that's just rearranging that formula. So therefore, if we've got the integral of x squared cos x cubed dx, it's equal to 1/3 cos u, okay, 1/3 cos u du, because du over a third, a third, du by a third equals x squared dx. Okay, 1/3 du equals x squared dx. So we can replace the x squared dx by a third du, and we can cross the x cubed by the u. So that then we can integrate that. So we integrate that, and we get 1/3 sine u. Okay, and then we substitute back for u, which is x cubed, and we get sine x cubed, a third sine x cubed. So let's check that out. So what we did is we just substituted for u for x cubed, and then we differentiated that to see how it all worked out. So let's check that out. So we get y equals sine x cubed over 3. So we'll just check that out. So y equals, let u equal x cubed. So y equals sine u over a third. Okay, so dy by dx, there's the chain rule, equals dy by du dot du by dx. So du by dx, if u is x cubed, du by x is 3x squared, and dy by du equals cos u over 3. So if we put those together, cos u over 3 dot 3x squared, the 3's cancel out, and we get cos u dot x squared. Remember that u is x cubed, so we get x squared dot cos x cubed, which is what we started with. So that's all nice and proven with the check. And so that's pretty much brings us to the end of our that brings us to the end of Maths Quiz 10 and our little review of that. So hopefully that's given you some more experiences, and hopefully you can go into the tests and exams with a little bit more confidence and perhaps some ideas on how to deal with questions of this. There's no substitute for experience, so I would recommend that you find more similar examples and try and work through them, and find the example, find a good worked example, and the more of those that you can do and become familiar with, the better you will be, and the more ready you will be for your exam. So there you go. Cheers. See you.